8.2, solving linear systems by graphing, day 1. I want to split this in half. All right. I'll give you some time to get the definitions written for linear equation, which we have practiced and know. An equation that forms a straight line can be written in the form y equals mx plus b, slope-intercept form. System of linear equations, that's two or more linear equations with the same variables. Simultaneous linear equations are two or more linear equations that have the same solution. An intersection, that's when they have one solution when your two equations cross, and where they cross at that intersection, that ordered pair is the solution to the system. And then you have parallel lines, lines that do not intersect at all. And how many solutions do parallel lines have? Parallel lines have how many solutions? None. No solution. Okay, I'll give you a minute here to get the definitions written. All right, now that you've gotten the definitions down, let's practice. First thing to know is an ordered pair is a solution. All right, the ordered pair is the solution of a linear system. When the x and the y values are substituted in, you take the x and you plug it in, you take the y, you plug it in. All right, you substitute your x and your y in the original equations, and both result in a true statement. Well, what does that mean, they result in a true statement? Now, we've practiced this in the past a little bit. This is the first part of your worksheet today, your homework. Determine if the ordered pair is a solution to the given system of equations. Well, here's your ordered pair, 1 and 4. 1 and 4, your x and your y. What you need to do is substitute those in to these equations. Let's start with the first one. Y equals x minus 3. Well, what is our y? Our y is 4 equals x is 1. Does 4 equal, what is 1 minus 3? What's 1 minus 3? Negative 2. Does 4 equal a negative 2? No. Wah, wah, wah. That one does not work. All right? How about the other one? Let's try the other one. Does it work in this one? 2x minus y equals a negative 2. What does 2x mean? 2 times x. Good. And what's x? 1. Minus, what's y? Minus 4. Does that equal a negative 2?
Yes.
What is 2 times 1? 2. And then we have minus 4. 2 minus 4. Negative 2 equals a negative 2. Well, it works in that one. So it works in one, but not the other. So is it a solution to that system?
No.
No. Absolutely not. Your answer is no. That ordered pair is not a solution. They do not share that line or that point. Okay? Now, actually, the very first one we did, if you're confident in your math skills, which I'm confident in mine right here, and I would double check it, if I find that it doesn't work in the first one, do you even need to go on and do the second one? No, you wouldn't have to. You know right away that, oh, it doesn't work in that one, so I automatically know that it is not a solution. It has to work, where here it worked in this one, but in order for it to be the solution, it has to work in both of them. And this one did not. Only worked in one, so it is not a solution. All right, so now let's rewrite the second one so we can see our nice work and it's easily written. Here's our x and our y. Let's do the first one. Y, which is negative 2, equals 3 times x, which is 3, minus 11. This one will be x, which is 3, minus 2 times y, which is a negative 2, equals a negative 1. this a solution to that system? Yes or no? I'm going to give you a couple minutes to work it out on in your notes, on your board. Hold up yes or no if you think that that ordered pair is a solution to that system. All right, the majority won. Yes, the majority won, and let's prove it. This is a -2. What is 3 times 3? 9 minus 11 is -2. Everyone seemed to get that one right. Yep, it worked in that one. How about over here? 3 minus, what is our order of operation that we have to do?
-2 times -2.
What's a -2 times a -2?
+4.
A +4. What is 3 plus 4?
7.
Does 7 equal a -1? No, that one does not work. So therefore, the total final answer is no. That is not a solution. And this part right here is what's been tricking people today. They got the -4 there. They thought 3 minus 4 was a -1. So that is a positive. That's been stumping a lot of people. All right, now the graphing part. Graph each line using the slope and the y-intercept, because everything is in slope-intercept form. Y equals mx plus b. The intersection point where they cross is the solution to the system. Write the solution as an ordered pair and then check. All right, we're going to have to refresh our memory on graphing also using slope and y-intercept. So looking at this first equation that's already in slope-intercept form, because it's y all by itself equals mx plus b form, what is my slope in that first equation? Y equals mx, and we always say m is the slope. What is our m in this case? 1. So our slope is 1. What is my y-intercept?
3.
A +3. All right, now let's go over here. My y-axis, my y-intercept, always start where your y-intercept is, +3 on the y-axis then. That's our y-intercept. Now we need to use our slope to make our line off of that point. Our slope is a 1, but we need a fraction for a slope, so how do I make 1 into a fraction? 1 over 1, all right? So it's a positive slope, so you know your slope better go in a positive direction, otherwise you went the wrong way. Give me directions. Which way?
Right 1.
Nice. Right 1, up 1, right 1, up 1. And then left 1, down 1, left 1, down 1, and so on. Very important that you make your lines nice and straight, because you need to see exactly where these two lines intersect. And make them nice and long, so you can see, so you don't have to extend it later. I'm trying to grab mine. Let me move it. Oh well. I have to go right there. You can see where it's at. Let's do the next one. Alright. What is my slope in y equals 3x minus 1? My slope is 3. To make that into a fraction, what would it be?
3 over 1.
Which is the same as 3 over 1. What is my y-intercept?
-1.
A -1. Excellent. Don't just say 1, it has to have the sign that's in front of it. That's a -1. So our line's going to be going in the opposite direction now. So where do I start?
-3.
So where do I start?
-1.
A -1 where?
On the y.
This one or this one?
Y-axis.
On the y-axis, the -1. Now my slope, you said is?
Over 1 up 3.
Or no, excuse me, did I say a negative slope and negative y-intercept? A blooper there, whoops. We still have a positive slope. A positive positive 3. So rise over run. 3 over 1 is?
Over 1 up 3.
Yep. Right 1, up 3. Right 1, up 3. Oh, look what happens. I like to circle that spot when I get there. Right 1, up 3. When I get to my intersection, that's my solution, and I have a point right there. I like to circle it so I don't have to search for it later. I remember where it's at. Now you take and you make your line. And we have solved that system. Does that have one, none, or infinitely many solutions? One solution, and it is where it intersects at the point of what? Where does it cross? 2 and 5. So that ordered pair where it crosses is 2 and 5. That is my answer. Now to check it, you take your original problems, right here. Here's my x now, here's my y. What is y? 5?
Yeah.
Does 5 equal 2 plus 3?
Yes.
5 equals 5. That one works. How about this one? Y, which is 5, equals 3 times x, which is 2, minus 1. Does 5 equal 3 times 2 minus 1?
Yes.
That'd be 6 minus 1, which is 5. It works in both of them. So I know my work is right, my graph is right, and there is my answer. Ordered pair of 2 and 5. Make sure you put parentheses so you know it's an ordered pair. All right, we'll practice one more, and then you can start your homework. What is my slope?
1/2.
Yes, 1/2. All right, it's already in fraction form. My slope is 1 over 2, positive. What's my y-intercept?
5.
My y-intercept is the 5. Let's do this slope right away. What's the slope for this one?
-2. Over 2.
Negative 2 over 1, or just a -2, but I'm going to put it in fraction form because I know I have to graph it. And then what's my y-intercept for this equation? A -7. All right, so I'm going to give you a minute to graph both of these, and they will intersect. And then I want you to hold up on your board the ordered pair where they intersect. A little correction here, though, before you graph it. On your notes, you guys don't have a negative. You guys have a positive 2. So that's going to change it. So on your notes, yours is positive. It's different than from what I had on my notes. So change that to a positive 2. So we have what's in your notes. Okay, we'll graph the first one. Start at the positive 5. And that has a slope of 1/2. So rise over run, run 2, rise 1. Run 2, rise 1. Left 2, down 1. All right, that would be the first equation. Second one, we start at the -7. And that has a slope of a positive 2 over 1. So right 1, up 2. Right 1, up 2. If you keep going, you won't even have to rely on your straight edge. We intersect right there. I like to circle it. Easier to make your line. All those points. And now I know my intersection is at 8 and 9. That is the solution to that system. Now, on your first ones on your worksheet, we have people that are confused because how do you graph x equals 3? How would I graph x equals 3?
3 over 1.
X equals 3. It's not y equals mx plus b. It's just telling us x equals 3. So on your x-axis, where's the 3? Right here. You draw your line right there through the x-axis. X equals 3. What if it's y equals -4?
Horizontal line on the negative.
Nice. A horizontal line. Here's the y equals a -4. Cut the y y-axis in half. And so where these two cross right here is the ordered pair solution. I think that's the first one. You have to graph something like that on your homework. And then one other refresher. If I have y equals 2x, what's my slope? Y equals 2x. What's my slope? You have one like this in your homework also.
0.
My slope is 2. What's my y-intercept? 0. They don't go plus 0, but we know that if there's nothing written there, we know that you're going to start that one at the origin. All right, you can start your homework pages 3 and 4 in the packet.